Hi everyone, welcome to my channel. You are watching Mahendra tutorial. Today I would like to explain about ray diagrams, biconcave lens or diverging lens. Here we have only two situations. First one is when the object is placed at infinity. Here you can see it is a biconcave lens or diverging lens. When the object is at infinity, the rays which are coming from the infinity, those are parallel to each other, and those rays are parallel to principal axis. Here you can see these are the rays which are coming from the infinity object, like sun rays which are coming from the sun. These rays are parallel to each other. After refraction, you can see the rays are diverging here, and when we extend the diverging rays backward, those diverging rays will meet at one point, that is focus. So when the object is at infinity, the image is formed at focus. Characteristics of the image. Image is formed at focus. Virtual, erect, point size image is formed. When the object is placed at infinity, image is formed at focus. Virtual, erect, point size image is formed. Next, second case, if the object is placed at any position on the principal axis. Here you can see object is placed any position on the principal axis. In this case, where is the image formed, we will see now. For example, object is placed here. First we need to take the ray which is parallel to the principal axis. It is a diverging lens, so the ray will be diverged, and when we extend this diverging ray backward, it appears coming from the focus. So this is the first refracted ray, and second ray we need to take which is passing through the optic center. It is undeviated, so it goes straight. Now these two rays are intersecting at this point. Here is the image formed. Now the characteristics of the image. Image is formed between focal point and optic center. So here is the image formed. It is formed between optic center and focal point. So wherever you place the object beyond C1, between C1 and F1, wherever you place the object in front of a biconcave lens, the image is always formed between focal point and optic center. And it is a virtual erect diminished image. It is a virtual erect diminished image. Next we will see one situation. Here is one question. Draw a ray diagram to locate the position of image when a point source is placed an optical axis MN of a convex lens in a such a way that it is beyond focal point. So it is a biconvex lens. There is a point size object on principal axis MN here. For this object we have to draw the image. So where is the image formed? To draw the image formation, first we have to draw a line which is perpendicular to the principal axis and it should pass through the focus. And also we have to draw a line which is passing through the optic center. So here is the ray, first incident ray we have to take. It is passing through the optic center. It is undeviated, it goes straight. This is the first ray, first incident ray. After drawing, next we have to draw the perpendicular line which is passing through the F1. So this is the perpendicular line and it is also called as a focal plane. And next we have to draw an incident ray from point of source to the lens. At any point you can draw the incident ray which is coming from the point of source to the lens. Draw a ray, and this is the ray coming from the point of source and it is striking the lens at P dash. After drawing this incident ray, we have to draw a ray parallel which is to the incident ray, and the parallel ray must pass to this optic center, and this is the parallel ray. It is parallel to the incident ray and it is striking the focal plane at F0 point. So here is the F0 point is there. After drawing this parallel line, now join this P dash and F0. When we join these 2 points here, the refractor ray will meet the principal axis at I point. So here is the I image is formed. Again we can see, when we join this P dash and F0, if we extend the ray, it will meet the principal axis at I point. So here is the image formed. So this is the image formation formed by a point size object when it is placed on the principal axis. Next we will see one more situation. Complete the ray diagram to show the paths of the rays after refraction through the lens. It is a biconvex lens and here is the incident ray. So first of all we have to draw the focal plane which is passing through the F1 perpendicular line to the principal axis. This is the focal plane, and afterwards draw the parallel line which is passing through the P. This is the parallel line and it is striking the focal plane at F0 point. Next join P dash and F0. This is the refractor ray what we require. So this is the way to draw the diagram, ray diagram. Next, complete the ray diagram. In this case here we have biconcave lens. This is the incident ray. To draw this, first we have to draw the line which is perpendicular to the principal axis and should pass through the focus, drawing the focal plane. And next second we need to draw a parallel line to this incident ray. So here we have to draw the parallel line. This is the parallel line and it is striking the focal plane at this point. Now next draw the line from this focal plane to the incident ray. So this is the refractor ray. When the incident light is falling on this biconcave lens, so this is the refractor ray path. So this is the way to draw the ray diagram when a light ray is incident on biconcave lens. Thanks for watching this video.